Thank you. Welcome, everyone. This is slightly better attended than the last time I did it, but don't worry. I'm Ian Tabor. This is Mick Fate. He's my old colleague from where I used to work. He knows roughly how to get stuff working, so he'll be around just to help you if I'm stuck at the front here. So let me start. Who am I? You could say I'm the ultimate car hacker because I built that thing 14 years ago. It has 3 ECUs, 2 of which I built. The third one is the electronic distributor, which was built by Ford, but it goes like stink. And it's a great little car to drive, but it has vaguely no electronics at all. There's a little disclaimer at the bottom here. If you brick your own car, it's not my fault. I made my Jag lose its gearbox. And with a 50 grand car, that's not a fun conversation to have with a dealer. I didn't have to have that conversation with a dealer. I just had to give it 3 weeks to learn how to change gear again. Don't do it unless you know what you're doing. Really, just don't. But, okay. So, when it comes to car hacking, I found a vulnerability a few years ago in my own vehicle, Citroen DS5, which is exactly the same head unit as what's in the suitcase at the end there, on the car in the box, in that you could tether through Wi-Fi, and that exposed a telnet port on the head unit, which then gave you access, gave someone access to the entire GPS history, telephone history, and your phone book, etc. The manufacturer was like, yeah, it's up to the user to secure their Wi-Fi. It's actually not. You really should get rid of the telnet port, but allegedly it's fixed now by disabling the Wi-Fi. You can still do the same hack over Bluetooth. Genius. So in 2018, last year, I did a talk about those findings in slightly more detail than that, and the process of actually disclosing it to the manufacturer. Very strange, weird French conference calls. I don't speak a word of French, never have done. That was just odd. But yeah, so I did DC 4420 last year in April, B-Sides London Rookie Track in June last year, and I actually spoke at DEF CON Car Hacking Village last year as well. That was scary. End of last year, I got invited to a Bug Crowd Live car hacking event in October over in America, where we found a major vulnerability in a vendor's vehicle. Got a nice little payout, which then paid for my car in the box to be built, which is now why I'm doing the Car Hacking Village UK. I was also part of a panel at DEF CON 27 this year with Cyber Gibbons, if you know him, and Spectres, who's from America. And I've been a bit of a busy year. There's been 8 different conferences this year so far. There's this one. I've got another one in a couple of weeks' time with Interpol, which is going to be scary because I'm on stage with Toyota, and they've got their own car hacking platform, and I've got my lovely car in a box. It's going to be a bit weird in front of a load of coppers. Honest Gov, I'm not going to steal your car. Yeah, you can quite easily. End of the month, I've got B-Sides Wales. That should be my last one for this year. Things might change. I don't know. One thing I will say is downstairs on the Hackers for Food Banks table, there is a limited edition Car Hack Village 44Con mug. What I normally do is produce these for people that help out with the conference and or the village. So there is one of 10 downstairs. If you want it, go and buy it. It helps out the charity. I didn't set the price, but if you've got some spare change, go and give it to them. They're doing it for a good cause. So on to the actual workshop. So workshop outline. We've first got the possible ECUs and attack surface. We've got how CAN bus, what CAN bus is, how the frame's laid out, the OBD2 connector itself, socket CAN and SL CAN, which is serial line CAN, which is what these clusters will use. And then you've got some possible software options that probably won't work today because the hardware is a bit limited in what it does, but you might be able to use it in the future if you actually get more involved in car hacking. So first things first, who here's got their own car? Who has tried to hack their own car? Who has broken their own car? No? Okay. If you're a car hacker and you say you've not broke your own car, you've either not been trying or you're lying, because normally you'll break something, hopefully not something fundamentally wrong. But if you know anything about cars these days, they are computers on wheels, preferably actually smartphones on wheels. The new Land Rover Freelander last week was released. That has 83 ECUs. I can't think of 83 places to put an ECU into a car, so I don't know where they bloody put them, but they're bloody everywhere. So here's a lovely little picture of all the different ECUs. Cars are getting smarter. You've got adaptive cruise control, adaptive lighting, airbag deployment, engine. Once upon a time, it was engine control. That was it. That was your computer. But you've got all this other interesting stuff. I won't read them out because it's just PowerPoint bingo. I'm not going to do it. I hate it when people do that to me. But there are a lot of things in a car. I will publish these at a later date through my website at some point. So there are a lot of attack surfaces, especially nowadays. Everyone seems to think, let's make them connected. Yeah, great. We'll give it Wi-Fi. We'll give it Bluetooth. We'll make it so that when it gets a certain distance from the house, it turns your bloody heating on. It's like, yeah, genius. Wonderful. Yeah. The whole thing about keyless entry. Great. Wonderful. Make sure you put your keys in a Faraday box inside your house, because otherwise someone will try a relay attack on you, especially if you've got a nice car. Just, yeah. And the safety case states that once they've got your car, it won't turn off until it stops. Genius. No. So, attack surface. This is sort of the attack surface as set out within the car hacker handbook. You've got cell network, Wi-Fi network, tire pressure monitoring system. They are very good at tracking vehicles. I have been told, but I have not confirmed this, but some councils use sensors that pick up tire pressure monitoring systems and monitor where the hell you're driving. They can also do the same with Bluetooth beacons. So if you don't want to be tracked, turn your Bluetooth off. It means you can't use your phone, but you can't be tracked. But the car can be tracked anyway. But the reason why CAN exists is once upon a time on the left, you had all your different ECUs connected by lots of different wires, which is a bit of a problem because in the late 90s, they were projecting that during the noughties, it would be about 57% of the vehicle's mass would be copper because of all the bits of cable going between all the different ECUs. So they had to come up with something meaningful. Bosch then came up with CAN, which is now used within cars, ships, planes, boats, industrial control systems, kitchens and things can use it as well. I don't know why, I don't know how. But yeah, it was introduced by Bosch in, I think, 1986. CAN network itself is just a simple two-wire twisted pair network. You've got a terminator each end, and then every ECU sort of hangs off that two-wire network. Normally, the terminator is either in the instrument cluster, which you have in front of you, or in the body control module, which is sort of your main fuse box. You shouldn't need to put a terminator if you're ever doing CAN stuff yourself on your own device, unless you've got two devices talking back to back, in which then you will, because otherwise you'll get reflections on the end. CAN itself uses what they call differential signaling. So one pin goes high and one pin goes one voltage goes low. 0 is dominant, as opposed to 0 is dominant and 1 is recessive. So if you measure the voltage on the pins, you will normally get 2.5 volts, unless there's a message coming across, and then you'll get it will go up by probably about a volt and down by probably about a volt. So on here you've got 0, 1, 0, 1, 1, 0. The actual frame itself is structured like this. This is a CAN 2.0 frame with a standard length arbitration ID, which is 11 bits, which gives you 2048 possible CAN message IDs. The lowest message always wins. So if you want to kill a car, send message 0 with a load of rubbish in it, and all the other ECUs will eventually go to sleep if you send it fast enough, because it goes, oh, something's more important than me, I'm going to go to sleep. So if you want to be nefarious, I'm not saying do this. It might work, it might not. Most of the time it does. And the only way to get it back is actually power the thing off and power it back on. On here, you've got the color coding. The green is the arbitration ID, which goes from 0 to 2048. It's normally denoted in hex. So you'll see a 3-digit number, which will be the hex number, not actually the decimal number. The blue part is request remote. That is a special type of frame where if you set that, you're basically saying, can I have some data from ECU X? And then it will reply back with the required data that it requests for. You don't really see it much in a vehicle. Normally CAN is just fire and forget. You don't see much saying, give me some data. Here's the reply. The yellow one on here is the length of the message. A message can be anything from 0 to 8 bytes. 8 bytes long. So you've got either 0 bits or 64 bits of data. You can get a lot of data in 64 bits, but be careful. Some of those messages carry more than one message in those bits. So when you start playing with the clusters, the message for rev counter is the same message for the speedo. So you have to change them both at the same time if you want to change them both. And then all the stuff at the end is like CRC field and end of frame, which is just, you don't ever see that, so you don't really worry about it. If you've ever been trying to hack your car, you've got your OBD2 connector. This was originally set up in America by California State Emissions Board as a standard for emissions testing back when fuel injection cars came out, because they had to check that they were squirting the right amount of fuel in and getting the right clean air out of the back of it. So they had a standard. This has then gone forward to be adapted. This is the minimal. Well, the minimal is 6 and 14. If you've got a posh car and you don't want to get stolen by either a key reprogramming attack or someone trying to reprogram your car, where you've got the 12 volts, it's always online. Put a switch under the dashboard to turn the 12 volts off. So if they then come and try and plug something in to reprogram your car, it's normally fed by the thing they plug in from the car. So if that 12 volts isn't on, it's not going to work. So yeah, there was a spate a few years ago of lots of BMWs and high-end Fords getting nicked because you could break the window, plug into the OBD2 port, reprogram a key for the keyless ignition, start the thing and drive off without the alarm going off. Genius. Not a good idea. So onto Socket CAN. Socket CAN is a sort of wrapper within sort of Linux rather than Windows that allows you access to the CAN controller. This hardware here you have doesn't really conform to Socket CAN because it uses serial line CAN, and serial line CAN is an extension that sort of fits in the middle. But the drivers on the hardware, on the Arduino boards that you have, are a bit temperamental and don't initialize serial line CAN correctly, so it doesn't always work. So onto serial line CAN itself. Serial line CAN is based on the Loricel protocol, and here's how you would initialize this if you had a Linux machine and you had an adapter that would actually work. It works on some of my boards. It doesn't work on all of them. It doesn't work on any of them because they're a pain in the arse. It works in about 1 in 20 times, which is a bit temperamental, but I can show you how to use serial line CAN. It's vaguely human readable if you know what you're reading. So we'll come on to that in a second. There are some further information. So where it says minus lowercase s and then a number, those numbers denote the serial line speed, anything from 10K up to 1 meg. 1 meg is the maximum CAN 2.0. The other things there, -O means open, -C means close. Don't quite get when you start it. You have to open the device and then close the device, but it works when it works. -S is the serial speed. Dev TTY is your TTY port, and CAN0 is the name of the port you want it to be called. If you don't put CAN0 at the end, it is called SL CAN0 rather than CAN0, and then you have to modify your scripts and things accordingly. So for the fuzzing setup, there are at the top there is the command that you would use for a Linux device if slcand actually worked. At the bottom there is the commands you need to use if you want to use a serial port, either in Windows or Linux. It will work. The C is actually just a reset of the microcontroller. You can just press the reset button on top. There's a little red button on most of the clusters that will reset it. If you're lucky enough to get slcan working, you have 4 bits of software that are part of CANutils. CAN dump, which basically spews the entire contents of what's coming off the CAN bus to the screen and just keeps scrolling until it finishes. Normally it won't finish until the cluster goes to sleep, and it doesn't go to sleep very often. It will just keep spewing rubbish. CAN sniffer only shows the output of the messages that are changing by default. So if you're looking for a specific message when you're trying to look at your car, do CAN sniffer. It will get rid of anything that's not changing. And then when you flick a switch, you will see a message probably come back, and then a bit will change depending which bit is actually being used. So that's quite handy to use if you're trying to work out what's going on. Most of the time, to work out stuff on a car, the DBC files that they use are sort of closely guarded secrets, I would say. You can get hold of them if you work with the manufacturer, but you have to sign non-disclosure agreements and things, so you're not allowed to tell anyone about them, etc., etc. I have a few for a couple of different cars. I can't give you them. More than my life is worth. If I do that, I won't be allowed on any of these bug bounties again. So what you need to do is try and work out what those messages do yourself, either by fuzzing. If it's your own car, do not fuzz your own car, because you may make it jump the mileage or something stupid like that. And if you're on a PCP finance and you've got 10,000 miles a year and you jump it 20,000 miles, when you take the car back to the garage, they will charge you for those extra 20,000 miles, 10p a mile or whatever it is. If you can prove that there's no way you could have actually done that mileage, right, jump it 1,000,000 miles or 500,000 miles, and then go back and say, there's no way, even at 70 mile an hour, I could have done that distance in this amount of time since the last service. So it must be a glitch. So can you please fix it for nothing? Because it must be your car that's broken, and honest God, I didn't break it. Everyone laughs at that, but it's true. I know people that have done it with hire cars and taken it back and gone, yeah, I just got in it and it was at this really high mileage. I don't know why. And they believe them. People do say, if you're going to hack a car, hack a hire car. Problem is, if you find anything, if you try and disclose that to the manufacturer, the first question from the manufacturers will be, whose car was it? And if you say it was Hertz, they'll probably be very cross with Hertz, and Hertz will then put you on a blacklist and you'll never be able to hire a car again. And that won't be just Hertz, that'll be all the different car manufacturers or all the different car hire companies, because they have a nice little friendly agreement between each other that if I blacklist someone, they'll blacklist someone as well. So be careful screwing around with hire cars. It's fun, but just know how to fix it if it all goes Pete-tong. Normally disconnect battery for about 20 minutes and everything sort of fixes itself. I can't guarantee that because I've not broken every car that I've ever owned yet. So on to the next bit, which is here are some examples of some messages as commands to send the messages to change the clocks that you have. Either at the top, you've got the speed to 50 mile an hour. All these clusters are from French vehicles. So actually all the odometers and speedos are actually in kilometers per hour by default. You just happen to have the bit of plastic on top of it that actually prints the miles per hour on the front. So 1E is not 50. It's somewhere around 800 or something in hex, because it's done in fractions of a kilometer. So some of those numbers don't make sense. 7E is for the rev counter. It's the first 11 bits of that message is the rev counter ID. And if you ever get to see a DVC file, it's a bit of a mind fuzz because some of it's in little endian, some of it's in big endian. So you'll have a bit of data that says you've got 64 bits of data that start at bit 63. How does that work? It starts at bit 63 and goes backwards. It doesn't start at bit 0 and go forwards. I had to write my own script to decode DBC files when I was working with a project, and it was just like, oh, makes sense now. God, when you're trying to work out where things are. So you've got here. I'll try and attempt to show you how this works. Actually, it's on the next bit. If you're using CAN-send, you've got CAN-send, the bus ID, then you've got your arbitration ID, which is your message number, then you've got a hash, and then you've got your 8 bytes of data. If you're using SLPAN through a serial port, you've got T, which means a normal message, and uppercase T means a extended message. You then have an arbitration ID, which is 3 characters in hex. If you put it through as decimal, you'll get the wrong answer. You then have the message length, which is here, and then you have your data, which is 8 bytes or 16 characters of hex. So on here, that's the wrong one. But on here, the speed is byte number 2, because they always start from 0. Genius. Rev counter is byte number 0, because again, it starts from 0. Now, I will go on to show you at the front here, if you can see it, there is my car in a box. This is most of the electronics out of a Peugeot 208. In front of you are clusters. Most of them are clusters from a Peugeot 208, which is the same as them. The odd ones at the end, the one at the front is a Citroen C4. The one behind is a Citroen C3 or a DS3, and the one at the back is a Peugeot 207. If you want to have a play with a cluster, the older it is, the cheaper it is. But the Peugeot 207 one was, I think, £13 if you just want to have a play and fuzz your own cluster. The 208 ones are about 30 quid each. If you get the boring one without the little matrix display in the middle. You can get a little matrix display in the middle, which shows you your sat-nav directions and things. They normally start at about 80 quid because they're very, very rare to get hold of. But my car in the box has got all the electronics from there. It is more or less a functioning car. At the moment, the wheel speed sensors don't work because I broke the thing that simulates it, because I need to do some work on it. But I do have some simulators on there, simulating the engine so that it thinks the crank is working, simulating the O2 sensor, so it thinks the O2 sensor is working. There's some very big resistors that get very, very hot, simulating the O2 sensor heater circuit. If you're going to go anywhere near it, please don't touch those big resistors. They get hot. You will get burnt. You have been warned. Last time I said that to someone, they went round, touched it, and went, "Oh, that's hot." It's like, I told you, you idiot. So the car in the box actually has 4 different CAN buses. Looking at the screen here, on the left-hand side, you've got your normal OBD2 port. At the bottom, you've got the body control module, which is the bit in the middle, which is normally your big sort of fuse box. You've got your main fuse box under the dashboard, under the bonnet, which also has an ECU in it of some description for your lights and stuff. And then you've got your ABS ESP, your power steering, and your engine ECU. They're on one bus, which is a high-speed bus at 500 kilobits. You've then got 2 low-speed buses. You've got the yellow and green one, which is your steering controls, which do your indicators and things. Your airbag ECU, which is not in the vehicle because I don't want to fill the form in when someone fuzzes it and makes an airbag go off and gets a big explosion in their face and a lot of powder everywhere. Makes a mess. There is some extra OBD2 ports on the back of the car in a box so that you can play with those buses themselves. If you get finished with fuzzing the ones at your desk, you can come and have a play. The blue CAN bus on here is your instrument cluster, the matrix within the instrument cluster, the head unit, the extra OBD2 port. And there is one final CAN bus that goes between the head unit and the screen for the head unit. And I believe that's used for the touch screen. But I wouldn't have done that personally. I'd just use SPI or something. But as it's a car, you might as well use CAN. But I will show you everything actually works. I'm going to confuse Cooper now. So we've got lights. I have a lovely little device here that injects messages as if it was the steering thing. It does disco mode. One of the crew members downstairs. So it does disco mode. So one of the crew members downstairs actually has a Peugeot 208, and he said I could play with his car as long as I guaranteed I didn't brick his car. I can't guarantee that, so he won't let me. So wouldn't it be fun to have it so that if it got to a certain speed, your car just went mental and started flashing its lights everywhere? I have another one here, which is slightly harder to play with, but and I think it might have broke. When it gets to 50 mile an hour, it makes your dashboard go absolutely mental. So all the lights flash as if there's major alarms going on. If you stop the vehicle, it turns off. Doesn't show up anywhere. So unless you know where it is, you basically have no knowledge of this thing. So if you wanted to play a prank on a mate of yours, borrow their keys at lunchtime, go and put it around the back of the dashboard, give them their keys back without letting them know. They drive home that night, get to 50 mile an hour. Oops. You could probably do it through the OBD2 port, but I haven't had time to actually sit down with it to work out how to do it. If anyone can see, you got the rev count on the left-hand side. It's currently off because the car is off. If I crank it, it will jump up to 650 revs, which is your default idle position. And now it's doing about 2,000 revs. And it beeps a lot. But if I play with this little dial here, you should see the rev count go down. It's now doing 7,000 revs. If I actually squirt the right messages, I can make it look like it's doing 158 mile an hour. There's no way a Peugeot 208 will do 158 mile an hour. It will shake itself to bits first. But if anyone wants to have a play, come and press some buttons. There's the washer bottle, which was originally going to have a bottle of whiskey attached to it, so that if you could get it to spit the whiskey out without using the switch, you got to drink it. Problem is, alcohol in cars are sort of frowned on, and every time you press the button, it did about half a litre. So it would get expensive for me and very drunk and messy for you. So I had to can that idea. But anyone wants to have a play, have a play. Let me go back to the lectern. So this is it in carrier mode. It folds away into 2 license boxes. This is it in my car. It takes up all the boot. It's been there for the last 3 months, and it'll be there for the next 3 weeks at least, because I've got a conference in 2 weeks' time, and then I've got B-Sides Wales. So you've got the smaller box, which is the head unit in a box. That will work on its own, because there's a little Arduino in the bottom left-hand corner in the little blue box that forges the 5 correct messages to make it think that it's in a car. That was fun. When I went to buy it from the scrapyard, it was like, excuse me, can I have the wires that go with it? And the bloke went, you've got the wires in the car you've got. And I went, no, I haven't. I'm putting it in my kit car. So I showed him a picture of my kit car, and he went, no, it'll never work. It'll never work. You'll never get it working. Challenge accepted. I had to buy half the car to actually work out what those 5 bloody messages were, to then work out how to get it working. But it will now work as an operational head unit without the rest of the vehicle. You can still do the hack over the personal area network by tethering it to your phone and then telnetting back across, and then you can play around with the file system if you want to do it. Be my guest. Just don't delete any of the files, because I don't have access to it if you brick it. There's no way to put it back. This is what it looks like when it's set up. You've got it in the reel down the bottom there. Finally, we got thank yous. The Grim Cyber team for their inspiration in the first place. Car Hacking Village in America. Steve Lord, 44 crew, and Cooper and everyone for being here, letting me be here, and for you lot for turning up. But now on to the fun stuff, which is the fuzzing and stuff. So have you all got the stuff plugged into your laptop? Control. So if you get the serial port running, you should get some output like this. If you press H for help, it will then, you then have to set up the serial ports, the SLCAN speed by doing capital S4 and then enter. L gives you a carriage return, and then O will actually start spewing data, which it should be doing, but it's gone to sleep. So if I undo that. So if you now watch as it scrolls past, you've got T, 2178, and then a number. 217 is actually the message that it sends out to the little subcluster to tell it what the speed is. So while you're doing this, if you watch at the front here, B68 7F001E. And hopefully when I hit enter, the rev counter is doing 50 mile an hour, and the speedo is doing 50 mile an hour, and the rev counter was doing 4,000 RPM. So it should swing across if you send the right text. If you play with that text, you'll make it go to different values. So instead of 7F, if I do 9F, it went up to just over 5,000 RPM on the left-hand side, and it was still doing 50 mile an hour on the other side. But you can send whatever you want. On the Python script, it makes it go into stupid disco mode. I need to start up my VM to actually show you that one, because I don't have Python in Windows because it's just a pain.
Okay. So you're going to look at the console. You try to get SLCAN out, or are you going to open the console just do
Just do it longhand to a serial port. Don't try and use SLCAN because it just doesn't work 99% of the time. Yeah. So Python on here on my machine, you actually need to be sudo to actually get it working, which can be a pain. But so if you look through the script, you look puzzled. Do you need a hand? Is everyone successfully playing around with the clusters? Everything working? If you want some other message IDs to play around with, OB6, OF6, 128, 217, and I think 218 will do other things. I could leave you to find them yourself, but you'll be there all day because it takes OB6, OF6, 217, 218, 127, I think also does something. One of them makes it do disco mode, so all the warning lights go on or off depending which bit you actually play with. If you want a way of fuzzing a cluster very easily, go through the 64-bit space by going through every bit. So go 1, 2, 4, 8, 16, 32, 64, 128, 256, all the way up to 2 to the power of 63. You'll be there forever if you try and walk every combination of 2 to the power of 64, because 2 to the power of 32 is 4.2 billion. I can't remember what 2 to the power of 64 is, but it's a bloody big number. And bearing in mind you have to do that 2,048 times, you'll be here a week, or possibly even further. If anyone hasn't got one of the little PCBs and wants one, give me a shout. You can make your own little CAN adapter with it. It's the same hardware that's on the back of the cluster, but as opposed to it's on the back of the cluster, it's on one side, this is on both sides. So just give me a shout, wave. I won't charge you for it. You can make a CAN adapter for less than £5. So you can have a play yourself at home later. Just don't break your own car. And if you do, you didn't blame me. Yep, no worries. It's about 12:05 now. It's probably about time to pack up if we can, please. Can you leave the cables and the clusters and things on the desk, and I will pack them away once you've gone. Any questions, feel free to get in contact with me offline through my Twitter or through my email address or my website. If you want one of these PCBs, let me know. I still have some left.
Will you release the slides?
I will do. I will put them on my website within the next week. It will take me a couple of days to do it. They'll be in PDF format probably, but everything that is used is on my GitHub anyway, so it's there. At Mintynet.